In this video, we are going to build another circuit by introducing two new components, the servo and the potentiometer. The potentiometer is going to allow us to have analog control of our Arduino. Analog control can be achieved using the analog input pins. Unlike digital pins that can only tell us if a voltage is 5 volts or 0 volts, high or low, an analog pin can tell us exactly where it sits in that range. We'll get a value of 0 if the voltage is 0 volts, and a value of 1023 if it is 5 volts. We're going to be using the analog read function to measure the voltage from our potentiometer. Now, a potentiometer has a knob on it that allows us to vary the voltage on that middle pin. So changing the position of the knob changes the voltage. This is the voltage we'll be reading with analog read. The servo is going to be the main output of this circuit. Servos are used for creating circular motion, and so we can put in a value to set a servo to a specific angle. Most servos have a range from 0 degrees to 180 degrees, and we do that by using PWM, the same concept that we use for changing the brightness of an LED. However, this PWM is slightly different, and so we will be using the servo library in Arduino to help us program. As you can see on the wiring, we have a button in place. I'm using this button so that the servo won't move unless the button is pressed. I'm simply not making the connection of that 5-volt cable if I let go of the button. The next thing we're going to do is build the circuit, so we need to go to the camera so we can assemble it. So with our servo, I've got one slightly different to the one on the slides. I'm going to put these jumper wires into the right pins. And on this one, this white cable along the band is actually what we're putting that PWM value through. So I'm going to place the button down here. Put ground to ground, voltage on one side of the button, and then bridge that voltage over with another cable. Going to put this PWM pin into pin 6. As the diagram says. And now we're going to introduce our potentiometer. So I'm going to put this in the board like this, so that each pin has its own row, otherwise they'll all be connected and it won't work. I'm going to connect one side to ground, connect one side to 5 volts, and I'm going to connect the middle pin to A0. So now that we've got everything wired up, we need to start programming. As always, we're going to start by assigning variables to our pin numbers. We're going to have an integer for the dial pin. It's going to be A0, which is the pin that is going to be able to measure the analog voltage. We're also going to initialize the servo pin, and this was wired up to 6. And the value of the dial is going to change, so we're going to give it a variable as well. In the setup, we're going to initialize the pin modes. Just be using the pin mode function. The dial pin will be an input because we are measuring it. And the servo pin an output. Before we get into writing the complete code, I'm just going to make sure this analog read is working, just so that when we get to the final product, we know that a smaller section of that product is working before we build everything on something that we are unsure of. So I'm also going to start serial, just to make sure that everything is working. We'll end up printing out the dial values. In the loop, I'm going to set dial to be that reading. We're going to analog read the dial pin. And we're going to serial print on an E line dial value. Everything's looking all good, so we're going to upload it. Alright, and now that it is uploaded, we're going to go to serial monitor. And we're getting some values through. So if I start turning the potentiometer, we're going to go down through the values. So 0 at one edge, all the way up to 1023. So knowing that that works, we're going to keep going. But to do that, I want to quickly introduce how we can write our own functions. We're using the pin mode function and the analog read function, but writing your own functions allows to make your code a lot simpler to read and a lot simpler to use. So we're going to quickly jump back to the PowerPoint slides. A function is made up of three main components: inputs, outputs, and the code. So we declare at the start of a function what data type we expect from that function, and a function can return any of the data types that we mentioned earlier. Two functions that are in every program we've wrote so far are void setup and void loop. The data type that these return is void, so nothing will come back from that function. And because there is nothing in those braces after setup and after loop, it has no inputs. If a function returns something other than void, we have to use a return statement to pass that variable back to where we used it. In this project, I'm going to be using the potentiometer to vary the speed of the servo. And to do that, I'm going to also use the map function, another one of Arduino's built-in functions. So the map function allows us to take a certain range of variables and squash them into another range, where the value we give it is placed in the same relative position along the new scale. I will be using this to translate that value I get from the potentiometer into a range of speeds that the servo arm will move at. So going back to our code, underneath void loop, I'm going to write a function. This function is going to return the amount of time I want to wait between loops. So this is going to return an integer. I'm just going to call this wait time. And inside these brackets is where the input will go. The input is going to also be an integer. This is going to be the potentiometer. And so we're going to be returning an integer. And to do that, we could do something like the integer x equals the map of potent. So these two values here are the minimum and maximum we expect before. And these ones will be the minimum and maximum we expect after we've mapped it. And then we can return x. This is perfectly valid, what I've written so far. But just to show you how we can make these things more concise, we can actually cut this out and replace x here. As you gain more experience with programming Arduinos, you'll see how we can make these shortcuts to make our lives easier. So with our new function, we need to create how we are going to move the servo. At the very top of the document, we're going to use a library to help us. The library we're going to be using is for servos. We're going to use a hash include to include someone else's code that we can then use. Don't worry about it too much for the moment, but basically how we've used pin mode and serial.begin already, we can just use these new functions around servos. So we're going to be introducing one of the control structures I mentioned earlier, which is a for loop. To change the angle of the servo, we need it to move from 0 degrees to 180, and then from 180 degrees back to 0. So we've got our start point, we've got our end point, then all we need to determine is how finely we want to move that angle. And I'm just going to say 1 degree. So for the angle of 0, and we're going to run this loop until angle hits 180, we're going to angle plus plus. So we're going to increment by 1 every loop. Now when I do this, currently I haven't got angle declared, so I'm going to go back here and declare angle. So typically, as I write code, I like to make comments before the functions itself, just to make sure that I understand how the code is flowing before I just start writing code. So in this line here, I want to move the servo to the angle. And then on this line, I want to wait a certain amount. And that will determine the rate that the arm moves. So after we finish this loop, we've started from 0, we've gone to 180, and we want to go back. So now that we're going to start at angle equals 180. We're going to go as long as angle is greater or equal than 0. And we want to do angle minus minus. And we're going to do the same thing. We're going to move the servo to the angle and then wait a certain amount. So how are we going to move the servo to a specific angle? To do this, we need to use the library that we included, Servo, and create a servo object. So up at the top, I'm going to make another heading, create servo object. We're going to write servo, and it's orange, so that's good. And we're going to make an object called arm. So in this statement here, this is the name of the object, and it is a servo object. In the setup, we need to initialize the servo. We're going to do this by going arm, which was this name here, dot attach. We're going to attach the servo pin. And then in these loops here, we're going to arm.write the angle that we want. And we need to do that in each one. So currently, as the code works, we're going to be reading the dial, and then we are going to be rotating through both sections of code. Now the problem with this is that the arm will have to go back and forth before we can change the rate at which it's moving. Now I want it to change as soon as I change the potentiometer. So to do that, we're going to have to read it every for loop. So I'm going to get rid of the serial. We know that works. Get rid of the dial, and we're going to read it at the start of each loop. And so this basically means that before we move to the next angle increment, we're going to measure the potentiometer. From here, we need to put in the delay. Now doing what I did below, where I had X, it's easier to just put this here. I'm going to do the same with delay. And in delay, I'm going to put in wait time, and that wait time is going to be based on the dial value. Now, the best way to figure out what's happening here is to follow the brackets. So starting on the innermost bracket, we've got dial. And dial is established here. So an analog reading from the dial. Then what's happening is we're using wait time, and we've got our input of dial. So in wait time, this potent is actually dial here. So dial is going to go in here, and it's going to use this map function and return this to here. Then what is returned is going to be the delay. If that doesn't make sense, these things do take time, but that's okay. We're just going to press on for now and see the results. So if I upload the code, I should have it that when I press this button, I'll be providing the power to the servo to actually respond to these instructions. If I turn the knob, it's getting faster. Now what you can see there is that the wait time is actually not enough for it to get to each angle position, so it's jumping because the servo is actually too slow. Alright, so now that we've learned how to control servos and about analog inputs, we're going to be moving to the next video in this series, which is going to involve automating that Google Chrome No Internet Dino Run game. And that's actually going to be pretty cool. So I'll see you in the next video.